Way back when, back in Algebra 1 even, you learned how to solve systems of equations. In Algebra 1 it was just 2 variables and 2 equations. In Algebra 2 we tacked on a third variable and a third equation. 3 equations, 3 variables. And now in this section you're learning how to use matrices to solve systems of equations very efficiently and easily. Of course, earlier in the year I showed you how to use a calculator to enter into what we called an augmented matrix and then use the command RREF, which stands for row reduced echelon form of that matrix, and that would give you the answers. What you're learning in this section is actually more powerful than the RREF. You're still using equations, but you're learning how to use matrices algebraically, which is a very powerful tool to have in your toolbox, especially when you go to college and you're in math classes. So, this is what you need to do. Another use of matrices in solving systems of equations, rather than using substitution or elimination methods, you can use matrices. Why does the inverse matter? Nobody asked me that in the last section, which is fine. The inverse undoes a matrix. So if I have a matrix equation, basically a matrix equation is just an equation that involves matrices. So this capital A is a matrix. This X right here, which would seem like our variable, that is a matrix. Actually, that's our variable matrix. And then we have equals B over here, which is also another matrix. So basically we have a matrix times a matrix equals some other matrix. This is a matrix equation. In order to solve for X, to get X by itself, normally if we have just a regular equation, like 3x equals 6, what would we do? You could divide by 3, that's kind of what we normally do, but really what we could do is multiply by what we call the multiplicative inverse of 3, which is the reciprocal of 3. But the multiplicative inverse of 3 is 1/3. So if we multiply both sides by 1/3, the 3 times 1/3 is just 1. X equals, and then of course we have the answer over there too. That's the same thing that's going on here. The multiplicative inverse here takes that 3 and turns it into a 1. The inverse matrix, remember if we multiply a matrix times its inverse, what do we get? What's that called? The identity matrix. A matrix with all 1s down the main diagonal and then 0s everywhere else, okay? Now the identity matrix is special because the identity matrix times anything just gives you your identity matrix back. Or not your identity matrix, it gives you that original matrix back. So if I multiply the matrix A here by its inverse, multiplying a matrix times its inverse gives me the identity matrix. And then the identity matrix times this matrix right here gives me just this matrix right here. Kind of like in this equation right here, how we turn that just into X equals. On the right-hand side, remember, naturally, if you do one thing to one side of an equation, you have to do the exact same thing to the other side. So on the right-hand side, we multiplied by the inverse matrix here, which means we must also multiply by the inverse matrix here. Now the important thing here is, remember that the commutative property for matrices does not hold. So if we multiply by the inverse matrix on the left, we must also multiply by the inverse matrix also on the left on the other side. If that inverse matrix was multiplied on the right, then we would have to also multiply by the inverse matrix on the right. So keep that in mind. This is left side, left side. It's very important. Now, once we're simplifying this down on the left, this is still the inverse matrix A times B. A inverse times B. And we still have A inverse times B here. So you'll do this multiplication here and you'll have your answer. So that's your matrix equation math that we're doing in this section. It's a very simple version of what we're going to be doing. Any system of equations can be written as a coefficient matrix times a column matrix of variables equal to another column matrix of constants. That's a lot of words to say something that's very simple to do. In other words, given the system, x plus 2y equals 9, 3x minus 6y equals 3, the matrix equation will be, I take the coefficients off of each of these and I form a matrix. 1, 2, 3, negative 6. That's the coefficient matrix. times a variable matrix. So that's a column matrix of my variables. My variables here are x and y. So it's just times x and y. Well, the 9 and the 3, so we have is equal to another column matrix of constants, and that's these guys right here. My answer matrix is on the other side, the 9 and the 3. So this is the matrix equation from the system of equations that I was given. Now if I wanted to multiply this back out, I could do that very easily. To multiply matrices, you multiply the row by the column to give you the element. 1 times x is 1x. 1x is sitting right there. 2 times y is 2y. 2y is sitting right there. Then my second equation, bottom row, 3 times x is 3x. Negative 6 times y is negative 6y. I'd have a 2-row, 1-column matrix. X plus 2y equals 9. And 3x minus 6y equals 3. So you have exactly the same thing. It's just represented in a different way here. And this is why it's called a matrix equation. So now you can solve for x and y by undoing the coefficient matrix. We want to turn this into the identity matrix. Once we turn it into the identity matrix times this will just leave me with x and y. If I multiply both sides by the inverse matrix to do that, then the inverse matrix times this will give me my answers. So what I want to do is find the inverse matrix here. How do we find the inverse matrix of a 2 by 2 matrix? Before that, find the determinant. You have to find the determinant first, because if the determinant equals 0, what happens? If the determinant equals 0, there is no inverse. And if there's no inverse, you won't be able to solve this equation. And if you can't solve this equation, there's no solution. Okay? And that's kind of the nice thing about using matrices. If you're doing this by hand, with like substitution or elimination, you don't know that there's no solution until you get to something weird. Well, just finding the determinant of this automatically tells you if there's no solution or not. So that's kind of a handy thing. All right, so we're going to take our matrix here and we're going to find the determinant. So the determinant of 1, 2, 3, negative 6 is, multiply the diagonals and subtract them. So 1 times negative 6 is negative 6, minus 3 times 2, which is 6. Negative 6 minus 6 is negative 12. So the determinant is negative 12, which means there is an inverse. So now we can set up the inverse. We have a to the negative first is what that looks like, but actually that says a inverse equals what do we write? So 1 over the determinant, which is 1 over negative 12. So 1 over 12, and I'll make it negative, times the matrix so you swap the A and the D. Negative 6 goes here, 1 goes here. You change the signs of B and C, so that's negative 2 there and negative 3 there. And now what do we do? Yeah, that's a scalar multiple up front, so you multiply that in, and you get negative 1/12 times negative 6 is positive 1/2. Negative 1/12 times negative 2 is positive 1/6. Negative 1/12 times negative 3 is positive 1/4. And then finally, negative 1/12 times 1, negative 1/12. So that's my inverse matrix. Now what we're going to do is set up that equation. So we have this equation sitting here. I'm going to multiply my inverse matrix on the left here and on the left here. And then we're going to start simplifying this down. So I write my inverse matrix, 1/2, 1/6, 1/4, negative 1/12, times my coefficient matrix, 1, 2, 3, negative 6 times my variable matrix, x, y, equals. I multiplied the inverse matrix on the left, so I must also multiply the inverse matrix on the left over here. So inverse matrix again, 1/2, 1/6, 1/4, negative 1/12 times my column, 9, 3. That's the setup. It seems like a lot of work here, but it's not that bad. All right, so now we're just going to simplify the left side, simplify the right side. I have to multiply a 2 by 2 times a 2 by 2. That gives me what dimensions matrix? A 2 by 2. So I'm going to have a 2 by 2. Now, row times column. So first position here will be the top row, first column. 1/2 times 1 is 1/2. 1/6 times 3 is 3/6, which is 1/2. 1/2 plus 1/2 is 1. Now, first row, second column. 1/2 times 2 is 1. 1/6 times negative 6 is negative 1. 1 plus negative 1 is 0. We're in good shape. Remember, we're supposed to find the identity matrix here. Okay, 1/4 times 1 is 1/4. Negative 1/12 times 3 is negative 1/4. Add those together and you get 0. So what should we get here? We should get a 1. 1/4 times 2 is 1/2. Negative 1/12 times negative 6 is another 1/2. Add them together and you do get that 1. So we got the identity matrix, which is nice. Our column of variables, x and y, equals don't use a calculator. You don't need it. 1/2 times 9 is 9/2. 1/6 times 3 is 1/2. 9/2 plus 1/2 is 10/2, which is 5. By the way, this is a 2 by 2 and a 2 by 2 times a 2 by 1, which will give me a 2 by 1 matrix. Outer dimensions are my new matrix. Okay, so we're good here on top. Let's go to the bottom. We have the bottom row times our column. 1/4 times 9 is 9/4. Negative 1/12 times 3 is negative 1/4. 9/4 plus negative 1/4 is 8/4, which is 2. See, you didn't need a calculator there. All right, so the identity matrix times my column is just going to give me my column, x, y, equals 5, 2. And we know that our corresponding elements match up, so that means x equals and y equals. So my answer is going to be the ordered pair. Since this is a system of equations, we write our answers as ordered pairs, 5, 2. No, it's not that bad. It's actually very interesting, I think. So let's set this problem up. So we have a matrix equation. We need the coefficient matrix, which will be what? 4, 6, 3, negative 6. And then my next matrix, the variable matrix, the column of variables, equals 32, 3. Okay, we want to solve this, which means we want to turn that coefficient matrix into an identity matrix. The way we do that is by finding the inverse matrix of the coefficient matrix, which means we need to start with the determinant. The determinant is, I could use these bars here, 4, 6, 3, negative 6, equals. So this is negative 24 minus 18, which is negative 42. That's correct. So that, therefore, there is an inverse, which means there is a solution to this system of equations. So now the inverse matrix is A inverse equals what? 1 over negative 42. This sounds like it's going to be awful. Actually, it's not that bad. This reduces pretty well. Okay, my coefficient matrix, negative 6, negative 6, negative 3, 4. The A and the D switched. These signs changed. Okay, distribute. Send in the scalar to each term. And we get negative times negative is positive. 6/42 is 1/7, which makes this 1/7. 1/14. Negative 2/21. So that is the inverse matrix. Now we set up the equation, multiplying the inverse matrix on both sides of the equation on the left. So this becomes my inverse matrix, 1/7, 1/7, 1/14, negative 2/21, times my coefficient matrix, 4, 6, 3, negative 6, times my variable matrix, xy, equals my inverse matrix again, 1/7, 1/7. I'm really squeezing this in here, 1/14, negative 2/21, times my answer matrix, which is 32, 3. All right, let's do this multiplication then. If you got it wrong, probably it's somewhere in the multiplication with a sign change or something like that. I want to verify that we have the identity matrix sitting here. So 1/7 times 4 is 4/7. 1/7 times 3 is 3/7 for a total of 1. 1/7 times 6 is 6/7. 1/7 times negative 6 is negative 6/7 for a total of 0. 1/14 times 4 is 4/14. Negative 2/21 times 3 is negative 6/21, which reduces down to has to be 0, but that's what we're doing right now. Okay, so 4/14 reduces down to positive 2/7. This reduces down to negative 2/7, which gives me 0. Finally, 1/14 times 6, 6/14. Negative 2/21 times negative 6 would be positive 12/21, which reduces down to yes, it does. It gives you 1 when you add those two together. Okay, so that becomes the identity matrix. We have xy still equals. Now this is going to be what dimension matrix? 2 rows, 1 column. So we have 1/7 times 32, 32/7. 1/7 times 3, 3/7. 32/7 plus 3/7 is 35/7, which reduces down to 5. 1/4 times 32 is 32/14. Negative 2/21 times 3 is negative 6/21. Weird numbers here. Let's go back and reduce this. 32/14 turns into 16/7. Negative 2 times 3 is negative 6, so we have negative 6/21. If I divide the top and the bottom by 3, I get negative 2/7. So I have 16/7 minus 2/7, which is 14/7, which is 2. So the answer is 5, 2. It's coincidence that this answer is the same as the last answer. There were two completely different systems of equations. All right, I want to redo this problem. I want to redo this problem on the calculator so that you can see how to do it. So let's get out our calculators here. And let's enter in these. Let's enter in these matrices here. I want to enter them in because I'm going to show you a bunch of stuff that we can do here. So let's enter in that coefficient matrix that we just worked on. To do that, you're going to press your template button, and the nice thing is you have a whole bunch of different matrices that you can select from. The 2x2 is there. A 2x1 is also there. Those are default templates, so you can select those. It's really nice. So I'm going to pick that one, and I'm going to enter in my coefficient matrix, which is 4, 6, and then 3, -6. And I'm going to press enter. I'm also going to enter in my answer matrix. So that was the 32, 3. It's a 2x1. So template, the 2x1 matrix, and then 32 and 3. Hit enter. The reason I'm doing that is because now that I've hit enter, I can go back and select those matrices and do things to them that otherwise I wouldn't be able to do if I just entered this in as one line. So let's go up here for a second and select this matrix. And the first thing we wanted to do when we did this by hand was calculate the inverse, right? Well, it turns out that these calculators understand that when you type in to the negative first power, you want it to find the inverse. So type in the exponent and then negative first power, press enter, and there's your inverse. Okay, now, so we have the inverse. Now we understand the math that we have to do here. On the left side, we multiply these two matrices together, and we wanted to find the inverse matrix, or not the inverse matrix, the identity matrix. So that's what we're going to do here. We're going to take the inverse matrix that we just found, this guy, and multiply it on the left times the original matrix here, and press enter, and we get the identity matrix. Now that we know that the identity matrix is on the left, we can do the same thing on the right. Multiply the inverse matrix times the answer matrix that we had. So go back up and select your inverse matrix. Go back up and select your answer matrix. And we get 5, 2.
Oh, and don't do it backwards because otherwise it says error and something.
So, yes, if you do it backwards, you're going to have a 2x1 times a 2x2, which you can't do. So it has to be on the left. It has to be the 2x2 times the 2x1, okay? Now, one other thing I want to show you. You can do all this at once. If all you're looking for is the answer, go back up and select your original coefficient matrix. On the left, what happens is you need that coefficient matrix, but you need the inverse of that coefficient matrix. So make it to the negative first, but don't press enter yet. Then press times, and go back up and get your answer matrix, the 2x1, 32, 3. Press enter, and now it's down there. You have the inverse matrix. You didn't calculate it, but it's there. Times the answer matrix, press enter, and you get 5, 2. So let's do this. Let's use the calculator and do the next problem, the system of two equations with two variables, using the calculator. Now on this one, because all I'm looking for is the answer here, I don't have to identify the inverse matrix or anything like that. All I need is the answer. I can type this in all as one line. So I need to go to my template. I'm going to bring up my 2x2 and the coefficient matrix. I just read it right off the system of equations, 5, 6, 2, 3. I'm going to raise that to the negative first power because that needs to be the inverse. Exit out of the exponent, press multiplication because you don't want to put that matrix in the exponent. That'd be a bummer. Now I'm going to press the template button again. I'm going to bring up my 2x1, and I'm going to enter in the answer column, which is -8 and -5. That's all the math I need to do. Press enter, and my answer is 2, -3. So now that you know how to do this on a calculator, what I'm going to expect to see on work is the actual matrix equation. So you would have to show me the, oops, it's not a 2, it's a 5. 5, 6, 2, 3. Your variable column, x, y, equals your answer column, -8, -5. And then you can give me your answer. What was it? 2, -3? There you go. Yep. On homework, you can use the calculator to do anything you want. Show me work. We're not done yet. I need to see this, though. I need to see this. And then you can give me the answer because you're doing it on the calculator, and that's perfectly fine. All right, one more problem here. We can extend this quickly to a system of 3 equations with 3 variables. The easiest way to solve any systems of equations is, of course, to use a calculator. And now you know 2 ways you can solve a system of equations using your calculator. Both involve matrices. So first, set up the matrix equation. Second, enter the matrix into the calculator, raised to the negative first power, multiplied by the constant matrix, what I just showed you. And then finally, the resulting matrix is your answers. And if you have 3 variables, you need to express your answer as an ordered triple, alphabetically, A, B, C, X, Y, Z, whatever it happens to be. So I need to see the matrix equation. Let's set that up. For my x's, I have 12.5, 1, and 2. Make sure that everything is aligned correctly. Make sure you're entering things into the correct columns and so on. What will my second column be? All right. Third column. Okay. So that's that one. And then what? X, Y, Z. All right. And then equals. All right. So before we go on, I want to stop you guys because everybody just made this mistake. And I kind of did this intentionally. The Y. Yeah, actually, if you look at this, it's a Y right there. That Y's in the wrong spot. The Y needs to be over here. So to do that, I have to subtract Y from both sides, which means this should actually be negative 1. And this should actually be 0. So watch out. On these problems on the homework, there are variables that are in the wrong spot or variables that are missing. If a variable is missing, it's going to be a 0. But if it's in the wrong spot, it might look like it's a different variable. So just be very careful how you're entering these things in. So you'll enter this into your calculator. This matrix, the 3 by 3, raised to the negative first, times this matrix right here. What do we get? Ten, 20, 10. Now the reason that your calculator is giving you a little decimal point after each one of those numbers, if you look, you see a decimal there? It's because of the fact that you have these decimals here. So it's defaulting to giving you a decimal answer, but they're exact, so they're just going to give you the 10 point. Those are the answers. And that's it for the section. 17 through 25 all. That's, 8, 9 problems, something like that? You're using a calculator. You should be able to crank this thing out pretty easily.